Hey, today I'm going to explain how we're going to make a voltaic cell, and this is the drawing that you're going to see on the Regents. This is an actual setup. But before I show you the actual setup, I'm going to show you basically in the drawing form. So what this all entails is we're going to have a piece of solid zinc and we're going to have some aqueous zinc. Just like here, I have a solid strip of zinc or any metal. And I'm going to have some aqueous zinc. This is the zinc nitrate that we're using in the lab. So in my diagram, I have this red bar is this bar, and this little square is the beaker, and this little liquid is the zinc aqueous solution. Going on the other side, I have solid copper, which is represented right here. This is the aqueous copper, which is the blue liquid, and then I have the beaker as well. Now, we also must have what is called a salt bridge. And what a salt bridge is for is it allows ions to flow back and forth between each solution, but it doesn't allow them to mix. So what I've done is I've filled up this tube with a salt solution, and I have plugged it with some cotton balls on the end. You put it in here. Now, oxidation and reduction happening. There's one thing that's missing that I'm not going to have on this because we're going to be doing this as a lab, is you should have a wire connecting the copper electrode to the zinc electrode. Once you complete this circuit, you're going to have an electrical current flowing through it. So let me show you what happens. We're going to, first of all, we have to look at table J because we have zinc and we have copper, and we want to figure out which one is oxidized. Remember, the one that is oxidized is the one that is losing electrons. The more active elements is oxidized. In other words, it loses the electrons. So I'm going to look at table J. I already know what it is, so I'm just going through the motions, looking through table J. Oh look, zinc is more active. So, zinc it's going to look like this. The formula so I have zinc solid, copper aqueous, zinc aqueous, copper solid. As you look here, if I needed to balance anything, I have a +2 here and a +2 here. So they're already balanced. This is a very simple, straightforward equation. So these are all going to be 1, 1, 1, 1. Now my half reaction, zinc is being oxidized because it is increasing in oxidation, while copper is being reduced because it is decreasing in oxidation. So in other words, my half reactions are going to be such that I'm adding 2 electrons. So on the oxidation, it's +2 electrons. On the reduction, it's 2 electrons are being added. These 2 electrons are removing. Remember, Leo the lion says GR. Loss of electrons is oxidation. GR, gain of electrons, is reduction. So let's look at how does this matter to my setup? Well, like I said, zinc is going to lose electrons. Now, I don't have a wire here, but just pretend I have a wire here. It's not going to show up on the camera anyway. But if I had a wire connecting these two, and I complete this circuit. By the way, this right here, you may see it once in a while in the Regents. This just represents a switch. So when I close this switch, I'm completing this whole circuit. And the electrons are going to flow. But like I said, the electrons are going to leave the zinc, and they're going to travel to the copper. So, we're looking at this, and I told you already that the salt bridge is for ions. Ions move through the salt bridge. Electrons are moving through the wire between the electrodes. So because zinc is oxidized, zinc is losing the electrons. Those electrons are flowing through the wire from the zinc electrode to the copper electrode. Now we have two additional vocabulary words. We have cathode and we have anode. Cathode and anode. Okay? Now an anode starts with a vowel. What else starts with a vowel? Oxidation. The anode, the current is leaving. The current is leaving the anode, so it's leaving the zinc. Where oxidation occurs in the anode. Reduction occurs in the cathode. So if you think about it this way, the two vowels match up, the two consonants match up. Another way that I remember it, and I always think about this if I ever get mixed up, I always think of an acid. Anode, current is departing. Anode, the current, or the electrons, is departing. And the only way that the electrons can travel is through the wire. And you know this from power cords and charging your phone. You got to plug in the wires into the wall. The electrons go through the wires. Electrons do not go through this salt solution. Ions travel through the salt bridge. Electrons travel through the wire. Again, the more active metal, higher on table J, is going to be oxidized. It's going to be the anode. Anode, oxidation. Cathode, reduction. This is your diagram. There are plenty of questions. I want you to set up, for practice problem, I want you to tell me which one is the anode and which one is the cathode. Okay? Peace.